Okay, for something we're doing next class, I need you to have some memory of Lewis structures. Not nearly as much as we did last semester, not all of the VSEPR stuff where you had to name the shape and the angle, none of that, but just to draw out a quick Lewis structure. So I'm going to give you a really quick guide. I want you to take notes on this so you have them in your notebook for next class when I need you to be able to do this stuff. So we'll start with an easy example, CH4. First thing we want to do is add up our valence electrons. So based on the column of the periodic table it's in, hydrogen being the first column, the next one over being second, we skip the middle, third, fourth, fifth, sixth, seventh, eighth. So the noble gases are the eighth column. Based on the column, that's how many valence electrons there are. Carbon is in the fourth column. Make sure you find it and know what I'm talking about. 4 valence electrons. Hydrogen's in the first, but we have 4 of them. So in total, I have 8 electrons to work with in my structure. Reminder, if you have a carbon, it goes in the center. Everything else goes around it. You're going to connect with bonds until you've used up all your electrons and everyone's happy. We defined happy as everyone having 8. There were some exceptions. The only exception you need to remember is that hydrogen's happy with 2. So 2, 4, 6, 8. I've used all my 8 electrons. Carbon believes it has 2, 4, 6, 8. Happy. Each hydrogen believes it has 2. Happy. We're done. Basic Lewis structures like this are what I need you to be able to do. So teaching you a couple tips and tricks that will help without you having to remaster this whole process. Tips. So as we said here, carbon goes in the center if you have a carbon. If I give you something like C some number, H some number, C3H8, C2H4, C50H102, what you're going to do in this case, and this is new, you're going to make a string or a line of carbons, and then you'll surround them pretty evenly as you can, with your hydrogens. I'll show an example of that later in this video. Again, while you're checking to make sure everyone is happy, some shortcuts that will help is know that carbon makes 4 bonds. It can be 4 single bonds, it can be 2 double bonds, it can be a double and 2 singles, but carbon always wants 8, and just pattern recognition over time, you've never seen carbon with a lone pair. So make sure every carbon always has 4 lines, bonds, coming out of it. Similarly, hydrogen makes only 1 single bond. It's happy with only 2 electrons, so make sure anytime you draw a hydrogen, there's only 1 line going to it. You never have to rethink. These tips kind of speed up the whole process when you're checking for the ones we're doing. Showing you a couple, and then I'll ask you to pause the video and try a couple, unpause the video and see if you're right. So for a couple to try, let's start with one of these ones that are new, kind of weird. Example, so we'll do C2H4. Okay. Carbons in a line surround with hydrogens. So 1, 2, 3, 4. These didn't have to be on the bottom, they could have been on the top, or those could have been there, but they're pretty evenly surrounding the carbons. Counting my total, 2 carbons that each have 4 valence electrons based on the fact that it's in the 4th column. 4 hydrogens that each have 1, so 8 plus 4, 12 electrons. Just watch, I'm just going to draw bonds. 2, 4, 6, 8, 10. I only have 2 more electrons to draw. Because of this, I know that carbon each needs 4 bonds. They each only have 3. So 2, 4, 6, 8, 10, 12. You can double check everyone's happy, but I have the right number, and these tricks helped me get there a little quicker. That's one example. Another example is, say, O2. 2 oxygens that each have 6 valence electrons, so I'm, again, working with 12. There's no central atom here because I just have oxygen. 2, 4, 6, 8, 10. I have 2 more to place, but the oxygens right now each only have 6 electrons. So again, it's going to be a double bond that does it. Ones that are as simple or difficult as these is really all I need to be able to get. So you're going to write down these next ones to try. Pause the video while you try them, and then I will solve them. And after that, I will tell you how to prove to me how you watched the whole video. So examples, ones you should try. Try carbon dioxide. Try water. Try N2. And try C3H8. Pause the video, try those. Okay, if you tried them, hopefully you did. Carbon, oxygen, oxygen, 4 plus 2 times 6, so that's 16. 2, 4. I know carbon makes 4 bonds. 6, 8. 10, 12, 14, 16. Everyone's happy, you can double check. Water, 2 times 1 plus 6 is 8. 2, 4, hydrogens are already happy. 6, 8. N2, 2 times 5 is 10. That's a little low. I don't know if you can see that. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. But each nitrogen only has 2, 4, 6. 2, 4, 6. Sharing these, 2, 4, 6. But this one at least now is 2, 4, 6, 8. Doing the same thing, 2, 4, 6, 8, 2, 4, 6, 8, but in total 10. Finally, C3H8, 3 carbons that each have 4, 8 hydrogens that each have 1. That is 20. Putting my carbons in a line, my hydrogens around them. So 1, 2, 3, 4, 5, 6, 7, 8. Starting with bonds, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I use 20. All my hydrogens have 1 line. All my carbons have 4. I'm done. To prove to me that you watched this whole video, on your Hess's Law homework, draw a picture of a dog. It doesn't have to be good, but then I'll know you watched the video. That's it.